For more than a century, the Big Bang has been described as the beginning of the universe, a moment when space, time, matter, and energy suddenly emerged into existence. But what if that picture is incomplete? What if the Big Bang was not the start of everything, but only the earliest chapter we can currently observe? Modern physics has revealed a surprising possibility. The deeper we investigate the foundations of reality, the harder it becomes to identify a true first moment. Some theories suggest that cosmic history may extend far beyond the limits of the observable past. Others propose that the universe never emerged from nothing at all. Tonight, we explore one of the most radical ideas in cosmology, the possibility that the universe may never have had a beginning. Human beings are naturally drawn to beginnings. We ask when a city was founded, when a civilization emerged, when a species evolved, and when a person was born. Our everyday experience teaches us that everything seems to have a starting point. Every story begins somewhere. Every journey starts with a first step. Every structure has a moment when construction begins. Because of this, we tend to assume that the universe must also have a beginning. For generations, this idea seemed perfectly reasonable. If stars form and eventually die, if planets come into existence, and if galaxies evolve over time, then surely the universe itself must have originated at some specific moment in the distant past. The Big Bang appeared to provide that answer. According to modern cosmology, the universe was once far hotter, denser, and smaller than it is today. As space expanded, the cosmos evolved into the vast structure we now observe. For many people, this naturally led to the conclusion that the Big Bang was the absolute beginning of everything. But a fascinating question emerges when we look more closely. What if the Big Bang was not the true beginning? What if it merely marks the earliest point we can currently observe? This possibility changes the entire conversation. Imagine reading a book and discovering that the first chapter is missing. The story begins on page 20. Characters already exist. Events are already unfolding. Relationships have already formed. The reader naturally wonders what happened before the visible story began. The Big Bang may present a similar situation. It might represent the earliest chapter available to observation, while earlier chapters remain hidden beyond our current ability to investigate. As scientists explored the mathematics of cosmology, they encountered a surprising problem. The equations describing the expanding universe work extremely well when applied to the period after the Big Bang. They successfully explain the formation of galaxies, the existence of cosmic background radiation, and many other observed features of the universe. However, when those equations are pushed all the way back toward the supposed beginning, difficulties emerge. Conditions become increasingly extreme. Temperatures rise enormously. Densities approach unimaginable levels. The mathematics breaks down. Physicists encounter what is known as a singularity, a point where current theories can no longer provide meaningful descriptions of reality. This creates an important distinction. A singularity does not necessarily prove that the universe began there. Instead, it may indicate that our current understanding becomes incomplete under such extreme conditions. In other words, the apparent beginning may reflect a limit in our knowledge rather than a limit in reality itself. This realization opens the door to deeper questions. If the Big Bang is not the ultimate beginning, what came before it? Could there have been an earlier phase of cosmic history? Might the universe have existed in another form before the expansion we call the Big Bang? Could time itself extend beyond what we currently regard as the first moment? These questions challenge one of humanity's oldest assumptions. We are accustomed to thinking that every effect must have a cause, and every story must have a first page. Yet the deeper cosmology investigates the foundations of reality, the more uncertain the concept of an absolute beginning becomes. Some physicists suggest that asking what happened before the Big Bang may be similar to asking what lies north of the North Pole. If time itself began with the Big Bang, then the question might have no meaning. Others argue that the Big Bang could have emerged from an earlier state, meaning that cosmic history stretches further into the past than we can presently observe. The scientific community has not yet reached a final answer. What is clear, however, is that removing the assumption of a beginning immediately changes the questions we ask. Searching only for a first moment, we begin exploring whether such a moment is necessary at all. The mystery shifts from what started the universe to does the universe require a start in the first place? That question stands among the most profound ever asked. It challenges our intuition, our understanding of time, and our deepest ideas about existence itself. And once it is asked, the possibility emerges that the universe may be far older, far deeper, and far stranger than any simple story of beginnings can fully describe. For much of the 20th century, the Big Bang was widely described as the moment when the universe began. Textbooks, documentaries, and scientific discussions often presented it as the ultimate starting point of reality, a moment when space, time, matter, and energy suddenly came into existence. This interpretation became deeply rooted in the public imagination and remains one of the most common ways people think about cosmic origins. Yet as cosmology has advanced, many scientists have become more cautious about describing the Big Bang as the absolute beginning of everything. The reason is simple. The Big Bang theory was never originally designed to explain the creation of the universe from nothing. Instead, it was developed to explain how the universe evolved from an extremely hot, dense state into the expanding cosmos we observe today. This distinction is important. The theory successfully describes what happened after the universe reached that hot and dense condition. It explains how matter formed, how the first atoms appeared, how galaxies emerged, and how the large-scale structure of the cosmos developed over billions of years. What it does not necessarily explain is whether something existed before that state. Imagine arriving at a theater halfway through a movie. You can observe the characters, understand much of the plot, and follow the events unfolding on screen. However, the story did not begin when you entered the theater. Earlier scenes may have established important details that remain hidden from your view. Some physicists believe the Big Bang may represent a similar situation. It could be the earliest chapter currently visible to science rather than the first chapter that ever existed. One reason for this possibility comes from the limitations of our current theories. As astronomers look deeper into the past, they can observe conditions that existed closer and closer to the Big Bang. The cosmic microwave background radiation, for example, provides a snapshot of the universe when it was only about 380,000 years old. Other observations allow scientists to infer conditions that existed even earlier, yet there is a boundary beyond which our understanding becomes uncertain. When researchers attempt to trace the universe all the way back to the exact moment of the Big Bang, the mathematics becomes increasingly difficult. Temperatures rise to extraordinary levels, matter behaves in unfamiliar ways, gravity becomes immensely powerful. The equations of general relativity produce a singularity, a point where density and curvature appear to become infinite. Most physicists do not view this singularity as a complete explanation. Instead, many regard it as evidence that our current theories are incomplete under such extreme conditions. After all, infinities often signal that a scientific model has reached the edge of its usefulness. A map may accurately describe a city, but it cannot explain the entire planet. Similarly, general relativity works remarkably well in many situations, yet it may require a deeper framework to describe the earliest moments of cosmic history. This is where new ideas begin to emerge. Some cosmological models suggest that the Big Bang was not the birth of the universe, but a transition from an earlier state. According to these possibilities, the hot, dense phase we call the Big Bang may have been preceded by something else entirely. One proposal is known as the bouncing universe model. In this scenario, the universe undergoes cycles of contraction and expansion. Instead of beginning from nothing, a previous universe collapses inward before reaching an extremely dense state. Rather than ending completely, the contraction reverses and becomes a new expansion phase. The Big Bang would then represent a bounce rather than a beginning. Another possibility comes from certain approaches to quantum gravity. These theories suggest that quantum effects may prevent the formation of a true singularity. Instead of space and time reaching an absolute endpoint, the universe could pass through a transition where familiar concepts of space and time behave differently. Cosmic history may extend beyond what appears to be the beginning. There are also ideas involving eternal inflation. According to inflationary cosmology, the observable universe may be only one region within a much larger cosmic structure. New regions of space could continuously form while others evolve independently. If this picture is correct, the Big Bang that created our observable universe may not have been the beginning of all existence. It may simply mark the birth of our local cosmic region within a much larger reality. What makes these possibilities so fascinating is that they shift the focus of cosmology. Asking what happened at the beginning, scientists begin asking whether the beginning was truly a beginning at all. The question becomes less about creation from nothing and more about understanding what larger process may have produced the conditions observed in the early universe. This represents a major change in perspective. Many people imagined cosmic history as a straight line starting at a single moment and moving forward through time. Modern theoretical physics increasingly entertains the possibility that reality may be more complicated. The visible chapter may not be the first chapter. The observed expansion may not be the first expansion. The history we can currently reconstruct may represent only a portion of a much larger story. None of these ideas have been proven conclusively. The earliest moments of cosmic history remain one of the greatest mysteries in science. Observational evidence becomes increasingly difficult to obtain as we move closer to the Big Bang. Researchers continue searching for clues that might reveal whether an earlier phase of reality existed. Yet the fact that these possibilities remain scientifically viable is remarkable in itself. It means that modern cosmology no longer assumes with certainty that the Big Bang was the absolute beginning of everything. Many physicists view it as the beginning of the observable universe. A subtle but profound distinction. The difference may seem small, but its implications are enormous. If the Big Bang was not the first chapter of cosmic history, then reality may extend far beyond the limits of what we can currently observe. The universe may possess a deeper past hidden behind the veil of the earliest detectable moments, and somewhere beyond that veil may lie answers to questions humanity has been asking for generations. What came before? Did the cosmos emerge from a previous state? Is there a larger reality beyond our observable history? The possibility that the Big Bang is not the first chapter keeps all of these questions open. It reminds us that the story of the universe may be far longer than we once imagined, and that the earliest page we can currently read may not be the first page ever written. When we look into the depths of space, we are also looking into the past. Light travels at a finite speed, which means every distant object is seen as it existed long ago. A galaxy located millions of light years away appears as it was millions of years in the past. The farther we look, the farther back in time we see. This remarkable fact has allowed astronomers to reconstruct much of cosmic history. By studying distant galaxies, ancient radiation, and the large-scale structure of the universe, scientists have traced the story of the cosmos back billions of years. Modern observations can reveal conditions that existed when the universe was still very young, yet eventually, a limit appears. No matter how powerful our telescopes become, there is a point beyond which ordinary observation cannot reach. This boundary is one of the most important ideas in cosmology. The earliest light we can directly observe is the cosmic microwave background, released approximately 380,000 years after the Big Bang. Before that time, the universe was filled with a dense plasma of charged particles. Light could not travel freely through this environment, because photons were constantly colliding with matter. The universe was effectively opaque. Trying to observe earlier times using light is like trying to see through a thick wall of fog. No matter how carefully you look, the view remains hidden. The observable history of the universe has a natural horizon. Beyond that horizon lies a period we cannot directly see. This does not mean nothing existed there. It simply means that our current methods of observation cannot reveal it directly. The distinction is crucial. Imagine standing on the shore of a vast ocean. The horizon limits what you can see, but no one assumes the ocean ends there. The visible boundary exists because of perspective, not because reality stops. Many cosmologists think the observable universe may work in a similar way. The earliest detectable moments might represent a horizon rather than an absolute beginning. Beyond that horizon, hidden depths of cosmic history could exist. The possibility becomes even more intriguing when we consider the limitations of modern physics. General relativity successfully describes gravity across enormous scales. Quantum mechanics accurately explains the behavior of particles on extremely small scales. Both theories have been tested repeatedly and have achieved extraordinary success. Yet, when scientists attempt to apply both theories to the earliest moments of the universe, difficulties arise. The conditions become so extreme that neither framework appears fully sufficient on its own. This suggests that important aspects of reality may remain hidden beyond the reach of current understanding. Some researchers believe that a deeper theory, often referred to as quantum gravity, may eventually reveal what occurred before the observable universe emerged. If such a theory is discovered, it could provide insight into regions of cosmic history that currently remain inaccessible. Several possibilities have been proposed. One idea suggests that the observable universe emerged from a previous contracting phase. In this picture, cosmic history extends beyond the Big Bang, with an earlier universe existing before the expansion we observe today. Another possibility is that our universe formed within a much larger cosmic environment. The observable cosmos would then be only a small region of a far greater reality. In such a scenario, what we call the universe might resemble a single island within an immense cosmic ocean. There are also theories proposing that space and time themselves may have existed in a different form before the earliest observable era. The universe we know could represent a transition from one state of reality into another, rather than an absolute beginning. Although these ideas differ significantly, they share a common theme. They all suggest that observable history may not encompass all of cosmic history. The visible chapter may be only part of a much longer story. This realization changes how we think about the past. Many people assumed that if something could not be observed, it fell outside the realm of scientific investigation. Modern cosmology has demonstrated that reality can leave indirect clues about regions beyond direct observation. Astronomers cannot see the interior of a star directly, yet they learn about it through the light the star emits. Scientists cannot observe black holes directly, yet they infer their existence from their effects on surrounding matter. Similarly, the hidden depths preceding the observable universe may leave subtle signatures that future observations could reveal. Researchers are actively searching for such clues. Patterns in cosmic background radiation, gravitational waves, and the large-scale structure of the cosmos may eventually provide evidence about events that occurred before the earliest visible moments. Each new discovery has the potential to expand the boundaries of cosmic history. The most profound implication is that the universe may be far larger and older than the observable portion we currently study. The visible universe contains hundreds of billions of galaxies and stretches across unimaginable distances. Yet even this vast realm may represent only a small fragment of a much deeper reality. The hidden depths beyond the observable universe remind us that observation has limits, but reality may not. What we can see is extraordinary. What lies beyond may be even more remarkable. The earliest light visible to our instruments may not mark the beginning of everything. It may simply be the oldest chapter still illuminated. Beyond that chapter could exist earlier eras, unknown processes, and forms of cosmic history that remain concealed behind the horizon of observation. Whether those hidden depths contain a previous universe, a larger cosmic structure, or something entirely unexpected, remains one of the greatest unanswered questions in science. The observable universe provides only part of the story, and beyond its earliest visible pages, a deeper history may still be waiting to be discovered. The deepest assumptions human beings make is that time must have started somewhere. Every experience in our daily lives seems to support this idea. A day begins with sunrise, a journey begins with a first step, life begins with birth, Because everything around us appears to have a starting point, it feels natural to imagine that time itself must also have a beginning. For many years, the Big Bang was interpreted in exactly this way. If the universe emerged from an extremely hot and dense state roughly 13.8 billion years ago, then perhaps time itself started at that moment. In this picture, asking what happened before the Big Bang would be like asking what lies north of the North Pole. There would simply be no before because time itself would not yet exist. This remains one possible interpretation. Modern physics has revealed that the situation may be far more complicated. The closer scientists examine the earliest moments of cosmic history, the more difficult it becomes to determine whether time truly began at the Big Bang or whether it extends beyond it in ways we do not yet fully understand. One reason for this uncertainty is that our current theories describe time differently. According to Einstein's theory of relativity, time is not a separate background against which events occur. Instead, it is woven together with space into a single structure known as spacetime. This means time can stretch, slow down, and behave differently depending on gravity and motion. Near a black hole, for example, time passes more slowly than it does far away from the black hole. This has been confirmed through both observation and experiment. If gravity can alter the flow of time, then the extreme conditions near the Big Bang may have affected time in ways that are difficult to imagine. The familiar concept of a universal cosmic clock may not apply under such extraordinary circumstances. As scientists trace the universe backward toward its earliest known state, space-time becomes increasingly compressed. Temperatures rise dramatically, densities become immense. Eventually, the mathematical descriptions provided by general relativity begin breaking down. This is one reason physicists suspect that an even deeper theory may be needed. If current equations become incomplete near the Big Bang, then our conclusions about the beginning of time may also be incomplete. In other words, the apparent starting point may represent a limit in our understanding rather than a true beginning of reality. Several modern theories explore this possibility. Some bouncing universe models suggest that the expansion of our universe was preceded by an earlier phase of contraction. In these scenarios, time does not suddenly begin at the Big Bang. Instead, it continues smoothly through a transition where a contracting universe becomes an expanding one. The Big Bang becomes a bridge rather than a starting point. An observer living in such a universe could trace cosmic history backward beyond the expansion phase and discover events that occurred before what we currently call the beginning. Other theories emerge from attempts to combine quantum mechanics with gravity. In certain quantum cosmology models, the earliest moments of the universe are not described by a singular point in time. Instead, the concept of a precise beginning becomes blurred. At extremely small scales, quantum effects may smooth out the conditions that appear to create a beginning in classical physics. Rather than a sharp starting point, reality may transition gradually between different states. Some physicists compare this idea to approaching the South Pole on Earth. As you move southward, the concept of further south gradually loses meaning, yet the surface itself remains continuous. In a similar way, the universe may possess regions where our ordinary understanding of time breaks down without requiring an absolute beginning. Another fascinating possibility comes from eternal inflation. According to inflationary theory, the observable universe may be only one region within a much larger cosmic environment. New regions of space may continuously emerge while others evolve independently. If this picture is correct, time may extend far beyond the history of our observable universe. The Big Bang would mark the beginning of our local cosmic region, but not necessarily the beginning of all existence. There are also cyclic models in which the universe undergoes repeated phases of expansion and contraction. In these scenarios, cosmic history stretches across countless cycles. Each universe gives rise to another. Each expansion follows an earlier contraction. Time continues through the sequence without requiring a single first event. The universe becomes part of an ongoing process rather than a one-time occurrence. These ideas remain speculative, but they demonstrate something important. The concept of a beginning is not as straightforward as it once seemed. For generations, people assumed that if the universe had a past, that past must eventually reach a first moment. Modern cosmology suggests that reality may not follow such simple rules. Time itself could be more complex than our intuition allows. The challenge is that human experience provides little guidance. We live within a limited span of time. Everything familiar appears to have a start and an end. As a result, our minds naturally search for a first moment in cosmic history. Yet nature has often surprised us by behaving differently from our expectations. The Earth feels stationary, yet it moves through space. Time feels universal, yet relativity reveals that it is flexible. Space appears empty, yet quantum physics suggests it is filled with activity. The beginning of time may be another example where intuition fails. There truly was a first moment. Time extends beyond the observable past in ways we have not yet discovered. Science does not possess a definitive answer. What makes this question so profound is that it touches the foundations of existence itself. If time continues beyond what we call the beginning, then the Big Bang may represent only one chapter in a much larger story. The observable universe would no longer mark the start of everything, but rather a transition within an ongoing cosmic history. In that case, the deepest mystery would shift. The question would no longer be what happened at the beginning. It would become, how far back does time truly go? And the answer may reveal that the history of reality extends far beyond the limits of what we currently call the beginning. Few ideas challenge human intuition more deeply than the possibility that reality may have no first moment. From childhood, we learn to think in terms of beginnings. Every book starts with a first page. Every building begins with construction. Every life begins with birth. Because beginnings are so common in everyday experience, it feels natural to assume that the universe itself must also have a starting point. But what if this assumption is wrong? What if reality does not follow the same pattern as the objects and events within it? This question has become increasingly important as physicists explore the deepest foundations of cosmology. While the Big Bang remains the best description of the early observable universe, it does not necessarily prove that reality itself began at that moment. Instead, it may simply mark the earliest point that current observations can reliably reach. The distinction is subtle, but profound. Imagine reading a timeline that extends back thousands of years. Eventually, the record ends because no earlier documents survive. The absence of records does not automatically mean history began there. It only means that our evidence stops at that point. Some scientists believe the Big Bang may represent a similar limit. The observable record reaches back to an extremely early stage of cosmic history, but reality itself may extend further into the past. If that is true, then there may never have been a first moment at all. This possibility forces us to rethink what we mean by the word beginning. A beginning implies a transition from non-existence to existence. Something was not there, and then it appeared. This idea works well for ordinary objects. A star forms from a cloud of gas. A planet emerges from material orbiting a young star. A tree grows from a seed. Yet reality as a whole may be different. If the universe includes all space, all time, all matter, and all energy, then asking what existed before reality becomes difficult. Any answer would seem to require something existing outside reality itself, which creates its own set of questions. For this reason, some cosmological models avoid the concept of a first moment entirely. Instead of beginning from nothing, reality may be part of an ongoing process that has always existed in one form or another. One way to visualize this is to imagine a circle. A line has a clear beginning and end. A circle does not. No matter where you place your finger on its edge, another section exists before it, and another section follows it. Certain theories suggest that cosmic history may resemble a circle more than a line. In cyclic universe models, periods of expansion and contraction repeat across immense stretches of time. Each phase grows out of an earlier phase. There is no need for a single starting event, because the process itself continues indefinitely. Other theories propose an eternal cosmic background, from which observable universes emerge. In these models, Our universe may have a beginning, but the larger reality containing it does not. The distinction is similar to waves on an ocean. An individual wave has a beginning and an end. The ocean itself may continue indefinitely. The observable universe could be like a wave, while reality as a whole resembles the ocean. There are also approaches based on quantum cosmology that suggest the idea of a precise first moment may simply lose meaning at extremely small scales. Just as the concept of a perfectly sharp edge becomes difficult to define under microscopic examination, the notion of a single starting instant may dissolve under the conditions present near the earliest stages of cosmic history. Reality does not suddenly begin. It exists within a framework where the distinction between before and after becomes less clear than our everyday experience suggests. This possibility may seem strange, but history has repeatedly shown that the universe does not always conform to human intuition. People once assumed Earth stood motionless at the center of creation because that matched everyday experience. Later discoveries revealed a very different reality. Time itself was once thought to flow identically for everyone, everywhere. Einstein demonstrated that time can stretch and slow depending on motion and gravity. Again and again, nature has shown that the deepest truths often differ from what seems obvious. The idea of a beginningless reality may be another example. The universe does not require a first moment any more than a circle requires a first point on its circumference. The search for an absolute beginning reflects a limitation in human thinking rather than a feature of reality itself. Of course, this remains one of the great unanswered questions in science. No current theory has definitively proven that reality is eternal. Researchers continue searching for evidence that might reveal whether cosmic history extends infinitely into the past or whether a true beginning exists somewhere beyond our present understanding. Yet the possibility itself is remarkable. It invites us to imagine a cosmos where existence is not a story that started at a particular moment, but an ongoing reality with no absolute first page. If that picture is correct, then one of humanity's oldest questions may require a completely different answer. The mystery would no longer be what happened before the beginning. The mystery would be whether a beginning ever existed at all. And in that possibility lies one of the most profound ideas modern cosmology has ever considered. Reality itself may have no first moment. For much of human history, explanations of the universe often began with a creation event. Whether expressed through philosophy, mythology, or science, there has been a strong tendency to imagine reality emerging from a specific starting point. The idea feels natural because it reflects the way we experience the world around us. Houses are built, trees grow from seeds, stars are born from clouds of gas. Everywhere we look, things appear to have beginnings. As a result, many people automatically assume that the universe itself must have started in the same way. Yet modern cosmology has revealed a surprising possibility. Not every scientific model of the universe requires a creation event. In fact, some of the most intriguing theories suggest that reality may not need a moment when everything suddenly appeared from nothing. Instead, the universe may be part of a larger process that naturally avoids the need for an absolute beginning. To understand why, it helps to separate two ideas that are often treated as the same thing. The first is the Big Bang. The second is the creation of reality itself. Many people assume these concepts are identical, but cosmologists do not necessarily view them that way. The Big Bang theory describes the evolution of the observable universe from an extremely hot and dense state. It explains how the universe expanded, cooled, and eventually produced galaxies, stars, and planets. What the theory does not automatically explain is whether that hot and dense state was the ultimate beginning of existence. That question belongs to a deeper level of inquiry. As scientists explored the mathematics of the early universe, they discovered that some models work perfectly well without requiring a true starting point. Instead of beginning from nothing, these models describe reality as evolving from earlier conditions. One of the best-known examples is the cyclic universe. In cyclic cosmologies, the universe undergoes repeated phases of expansion and contraction. A period of growth is followed by a period of collapse. Eventually, conditions become extremely dense and a new expansion begins. The process repeats again and again. In such a model, there is no need for a first cycle. Every cycle emerges from an earlier one. The universe resembles a rhythm rather than a one-time event. Just as a swinging pendulum moves back and forth without requiring a new beginning for each swing, the cosmos could move through endless phases of cosmic evolution. Another example comes from bouncing universe theories. These models propose that the observable expansion of our universe was preceded by a contracting phase. Instead of a singular beginning, the Big Bang becomes a transition point. Imagine a ball bouncing off the ground. The upward motion has a beginning from one perspective, but it originates from an earlier downward motion. Similarly, the expansion of our universe could be the result of a previous contraction. The Big Bang would then represent a bounce rather than a creation. This idea removes the need for a moment when reality suddenly appeared. Cosmic history continues through different phases. Some approaches to quantum gravity reached similar conclusions. Physicists know that general relativity works extremely well under most conditions, but it encounters problems when applied to the earliest moments of the universe. The equations predict a singularity where densities become infinite and the known laws of physics break down. Many researchers suspect that this singularity is not a real feature of nature. Rather, it may signal that a deeper theory is needed. When quantum effects are incorporated into cosmological models, the singularity often disappears. Instead of reaching a point where time and space cease to exist, the universe transitions through extremely dense states while remaining physically meaningful. In these scenarios, there is no requirement for creation from nothing. Reality continues through conditions that are difficult to describe using classical physics but do not represent an absolute beginning. Another fascinating possibility comes from eternal inflation. Inflation is the idea that the early universe underwent a period of extremely rapid expansion. Some versions of inflation suggest that this process may continue indefinitely on larger scales. In such models, new regions of space constantly emerge, while others evolve into universes like our own. The observable universe becomes only one part of a much larger cosmic environment. A local universe may have a beginning, but the larger inflationary process may not. This is similar to individual waves forming on the surface of an ocean. Each wave has a beginning and an end, yet the ocean itself continues existing independently of any particular wave. Our observable universe could be one wave within a much larger cosmic sea. What makes these models especially interesting is that they challenge one of the oldest assumptions in human thought. The assumption is that every chain of events must eventually trace back to a first event. In everyday life, this seems reasonable. If you see a row of falling dominoes, you naturally look for the first domino that started the sequence. But reality as a whole may not operate according to the same logic. Some mathematical models allow causal chains to extend indefinitely into the past. Others describe reality as existing within self-sustaining cycles. Still others suggest that concepts such as before and after may behave differently under extreme conditions. In these frameworks, the search for a first event becomes unnecessary. The universe simply exists as part of an ongoing process. This does not mean that cosmologists have proven the universe is eternal. Far from it. The ultimate origin of reality remains one of the greatest unsolved questions in science. Researchers continue testing different theories and searching for observational evidence that might distinguish between competing models. What is important is that modern physics no longer assumes a creation event is required. Many scientifically serious models function perfectly well without one. They show that the universe can be described mathematically without invoking a moment when all existence suddenly emerged from nothing. This represents a major shift in perspective. The question, what created the universe, was often treated as unavoidable. Today, some physicists are asking a different question. What if reality does not require creation in the way we imagine? What if existence is not something that began, but something that continuously evolves? The answer remains unknown. Yet the fact that such possibilities can emerge from rigorous scientific investigation reveals how much our understanding of the cosmos has changed. The universe may be stranger than our intuition suggests. Its history may extend far beyond the observable past, and the deepest truth may not involve a single moment of creation at all. Some cosmological models never require a creation event because they replace the idea of a beginning with something far more expansive, an ongoing reality that transforms, evolves, and persists without the need for an absolute first moment. If those models are correct, then the universe is not a story that suddenly started. It is a process that may have been unfolding far longer than we can currently imagine. Fascinating alternatives to a universe with a beginning is the idea that cosmic history may unfold through endless cycles. Instead of emerging from a single creation event and moving toward a final conclusion, the universe could pass through recurring phases of transformation, with each stage giving rise to the next. This possibility has attracted scientists for decades because it offers a way to explain cosmic history without requiring an absolute starting point. The idea may seem unusual, yet cycles are common throughout nature. Day becomes night, and night becomes day. Seasons repeat year after year. Water evaporates, forms clouds, falls as rain, and returns to the oceans. Even stars participate in cycles as old generations die and their material becomes part of future stars and planets. Nature often favors processes that repeat. Some cosmologists have wondered whether the universe itself might follow a similar pattern. In a cyclic universe, cosmic history does not begin with a unique event. Instead, periods of expansion and contraction succeed one another across immense spans of time. The universe grows larger, evolves, and eventually enters a new phase that leads to another cycle. The details vary between different theories, but the central idea remains the same. What appears to be a beginning may actually be a transition. Imagine watching a wave rise from the surface of the ocean. To an observer focused only on that wave, it might seem like a new event, yet the wave emerged from an ongoing process already underway. Another wave came before it, and another will follow. Some cyclic cosmologies suggest that the Big Bang could be similar. Rather than representing the birth of reality, it may mark the beginning of a new cycle within a much longer cosmic sequence. One of the earliest scientific versions of this concept was the oscillating universe model. According to this idea, the universe expands for billions of years before gravity eventually slows the expansion and reverses it. The cosmos begins contracting, becoming hotter and denser over time. Eventually, conditions become extreme enough to trigger a new expansion phase. The process repeats again and again. Expansion follows contraction. Contraction follows expansion. The universe has no ultimate beginning, because every cycle emerges from an earlier one. Although modern observations suggest that the universe's expansion is currently accelerating rather than slowing, the oscillating universe remains historically important because it introduced the possibility of an eternal cosmic rhythm. More recent theories have explored similar ideas in new ways. Some bouncing universe models propose that the universe never reaches a true singularity. Instead of collapsing into an infinitely dense point, quantum effects intervene when conditions become extremely extreme. The contraction reverses and a new expansion begins. The Big Bang becomes a bounce rather than a birth. In these models, the observable universe emerges from a previous cosmic phase rather than from absolute nothingness. The history of reality extends beyond what we currently call the beginning. Another intriguing proposal comes from the cyclic models developed within certain versions of string theory. In these scenarios, our universe may exist on a higher dimensional structure, sometimes called a brane. Periodically, interactions between such structures trigger enormous releases of energy that resemble Big Bang events. Each interaction initiates a new cosmic cycle. The universe experiences repeated eras of growth and evolution without requiring a single first event. Although highly theoretical, these ideas demonstrate how modern physics continues exploring possibilities that extend beyond traditional concepts of cosmic origins. What makes cyclic universes especially appealing is that they address one of the oldest philosophical questions. If everything requires a cause, what caused the beginning? A cyclic universe approaches the problem differently. Instead of searching for a first cause, It replaces the concept of a beginning with an ongoing process. Every cycle emerges from a previous cycle. The chain continues indefinitely. There is no need to identify an original starting point because the sequence itself never begins. This approach changes the nature of the mystery. The question becomes not what started the universe, but what governs the cycles. Researchers then focus on understanding the physical laws that allow expansion, contraction, and renewal to occur. Of course, cyclic models face significant challenges. One difficulty involves entropy. According to the second law of thermodynamics, entropy tends to increase over time. Entropy is often described as a measure of disorder or the number of possible arrangements within a system. If entropy increases during every cycle, one might expect each successive cycle to become more disordered than the previous one. Over an infinite past, this could create serious problems for cyclic cosmologies. Modern versions of cyclic theories attempt to address this issue in various ways. Some propose mechanisms that reset or dilute entropy during transitions between cycles. Others suggest that entropy behaves differently on cosmic scales than it does in more familiar environments. These questions remain active areas of research. Scientists continue investigating whether cyclic models can fully explain observations while remaining mathematically consistent. Despite these challenges, the concept remains compelling because it offers a radically different perspective on time and existence. In a cyclic universe, history is not a straight line with a clear beginning and end. It resembles a vast cosmic rhythm. Every ending becomes a new beginning. Every phase emerges from an earlier phase. The universe continually transforms without requiring an absolute origin. The idea also changes how we think about the Big Bang. Rather than being the first event in reality, it becomes one event among many. An important transition, certainly. A dramatic transformation, without question, but not necessarily the start of everything. The observable history of our universe would represent only one chapter in an endlessly unfolding story. The most profound implication concerns time itself. Human beings naturally imagine time as a path stretching from a beginning toward a future destination. A cyclic cosmos suggests a different possibility. Time may be part of a repeating process with no ultimate starting point and no final endpoint. Reality would not resemble a story with a first page. It would resemble a wheel that continues turning. Whether the universe truly behaves this way remains unknown. Current observations do not yet provide a definitive answer. Yet the possibility remains one of the most intriguing ideas in modern cosmology. The endless cycles that could shape an eternal universe invite us to imagine a cosmos where creation and destruction are not unique events, but recurring phases of a larger process. In such a reality, the Big Bang would not be the beginning of everything. It would simply be the latest renewal in a sequence extending far beyond the limits of observable history. If that picture proves correct, then the universe may not be a one-time occurrence at all. It may be an eternal rhythm of transformation, unfolding across time without a first moment and continuing long after any single cosmic cycle has passed. The idea of an infinite past is one of the most challenging concepts in cosmology because it forces us to rethink the way we understand both space and time. Human beings naturally think of time as a line with a clear beginning, a present moment, and a future stretching ahead. Every experience in our lives seems to reinforce this picture. We remember the past, live in the present, and move toward the future. But if the universe has existed forever, then this familiar picture may be incomplete. An infinite past would mean that there was never a first moment. No matter how far backward one traveled through cosmic history, there would always be an earlier chapter. Every event would be preceded by another event, and every era would emerge from an even older era. This idea sounds simple, yet its implications are profound. Consider the age of the observable universe. Modern measurements indicate that the universe has been expanding for approximately 13.8 billion years. This number already feels enormous. It is far beyond anything humans can directly comprehend. Entire civilizations rise and fall within a tiny fraction of that time span. Now imagine not billions of years, but an endless past extending without limit. The difference between a very large number and infinity is enormous. A universe that is billions of years old still has a beginning somewhere in the past. A universe with an infinite past never reaches a first moment at all. This changes how we think about cosmic history. Instead of asking what happened at the beginning, we would need to ask how reality can exist without one. The implications extend beyond time itself. Space and time are deeply connected through Einstein's theory of relativity. They form a unified structure known as space-time. If time has no beginning, then the history of space may also extend far beyond the limits of the observable universe. The cosmos could have experienced phases, transformations, and events that occurred long before the earliest era accessible to modern observation. The observable universe would become only a small visible section of a much larger story. Imagine opening a history book in the middle. The pages you can read contain countless events, but they are clearly not the entire narrative. Earlier chapters exist beyond the portion currently visible. An infinite universe would be similar. The cosmic history we can reconstruct today would represent only a tiny fragment of a reality extending indefinitely into the past. This perspective also changes how we think about causality. In everyday life, we often explain events by tracing them back to causes. A tree grows because a seed was planted. A building exists because people constructed it. We are accustomed to following chains of cause and effect until we arrive at an origin, but in an infinite past, the chain may never end. Every cause would have a prior cause. Every event would emerge from an earlier event. The search for an ultimate starting point would become impossible, because no such point would exist. For some people, this idea feels uncomfortable. The human mind often seeks closure. We want explanations that eventually arrive at a final answer. An infinite past appears to deny that satisfaction. Yet mathematics and physics frequently describe structures that extend indefinitely. Numbers continue without end. There is no largest number. Similarly, some cosmological models suggest that time itself may continue endlessly into the past. Another fascinating implication concerns the age of structures within the universe. If reality has existed forever, why does the universe still appear dynamic and evolving? Why are stars still forming? Why do galaxies continue changing? Why does the cosmos not appear infinitely old in every observable respect? This question has led cosmologists to develop models in which the universe continuously renews itself. Some cyclic theories propose that expansion and contraction erase traces of earlier eras. Other models suggest that cosmic evolution creates fresh structures even within an eternal reality. In these scenarios, the universe can have an infinite past while still containing regions that appear relatively young. The distinction is important. An infinite past does not necessarily mean that every object within the universe is infinitely old. Stars still form, galaxies still evolve, planets still emerge. Individual structures can have beginnings even if reality itself does not. A useful comparison is the ocean. Individual waves appear, grow, and disappear. Yet the ocean can exist continuously while its temporary structures constantly change. Similarly, stars and galaxies may come and go within a universe that has no ultimate beginning. The idea also affects our understanding of cosmic origins. If the universe has an infinite past, then many traditional questions may need to be reformulated. Instead of asking what happened before the universe existed, we would ask, how does an eternal universe evolve? Instead of searching for a first moment, we would investigate the laws governing an endless sequence of moments. The focus shifts from creation to continuity. This shift may seem subtle, but it fundamentally changes the way cosmologists approach the deepest mysteries of existence. An infinite past also raises intriguing questions about the nature of time itself. Is time truly fundamental? Or is it an emergent feature of a deeper reality? Could our perception of a flowing timeline be only one aspect of a larger structure? Some modern theories suggest that time may behave very differently under extreme conditions than it does in everyday life. If so, the concept of an infinite past may involve forms of temporal behavior that are difficult to imagine from a human perspective. What makes this possibility especially fascinating is that it challenges one of our most basic assumptions. For thousands of years, people have searched for first causes, first events, and first moments. An infinite past suggests that reality may not contain such a boundary. The universe would not resemble a story with a first page. It would resemble a narrative that extends indefinitely in both depth and complexity. Of course, no current theory has conclusively demonstrated that the universe possesses an infinite past. The question remains open. Observations continue to provide new clues, and future discoveries may support or challenge these ideas. Yet the possibility itself reveals how far cosmology has progressed. Scientists are no longer limited to asking when the universe began. They are now exploring whether the concept of a beginning is even necessary. If the past is truly infinite, then reality may be far older than anything we currently imagine. The observable universe would become only one chapter in an endless cosmic history, and time itself would stretch beyond every horizon we can presently see. In such a universe, the greatest mystery would no longer be the search for a beginning. It would be understanding a reality that never needed one. Few ideas in modern cosmology are as radical as the possibility that the universe was never born. For generations, scientists, philosophers, and ordinary people have searched for the moment when everything began. The question seems natural. If stars have beginnings, if planets form over time, and if galaxies evolve throughout cosmic history, then surely the universe itself must have started somewhere. Yet as our understanding of reality has deepened, a surprising possibility has emerged. What if the search for a cosmic birth is based on an assumption that may not be true? What if the universe did not begin at all? This question lies at the heart of one of the most ambitious investigations in modern science. Researchers are no longer only trying to understand how the universe evolved after the Big Bang. They are also exploring whether the Big Bang represents a beginning, or whether it is simply one chapter within a much larger cosmic story. The distinction is profound. Imagine walking into a theater and seeing a dramatic scene unfold on stage. The action is already underway, characters are speaking, events are occurring. From your perspective, the performance begins when you arrive, yet the play itself may have started long before you entered the room. The Big Bang may represent a similar situation. It marks the earliest chapter we can currently observe, but it may not mark the beginning of reality itself. This realization has motivated scientists to search for evidence of a cosmos that extends beyond the apparent beginning. The challenge is enormous. Unlike ordinary scientific questions, this investigation concerns a period that may exist beyond direct observation. Light from the early universe can only reveal so much. As astronomers look farther into the past, they eventually reach limits imposed by the physics of the young cosmos. Beyond those limits, direct evidence becomes difficult to obtain. Yet scientists have faced similar challenges before. No one has ever seen the center of a black hole directly, yet its existence can be inferred through its effects. No one has traveled to the interior of a star, yet its structure can be studied through observation and theory. In the same way, researchers hope that traces of a deeper cosmic history may still be visible today. One place scientists look for clues is the cosmic microwave background. This ancient radiation is often described as the oldest light in the observable universe. It provides a snapshot of conditions shortly after the Big Bang and contains an enormous amount of information about the early cosmos. Researchers carefully analyze tiny fluctuations within this radiation, searching for patterns that might reveal evidence of processes occurring before the observable era. Even subtle irregularities could potentially hint at events that preceded the expansion we call the Big Bang. Another promising area of investigation involves gravitational waves. Unlike light, gravitational waves can travel through environments that would block ordinary radiation. Some physicists hope that primordial gravitational waves may carry information from periods of cosmic history currently hidden from view. If detected and interpreted correctly, These signals could provide insight into conditions that existed before the earliest observable moments. They could become messengers from a deeper past. The search also extends into theoretical physics. Researchers working on quantum gravity, string theory, loop quantum cosmology, and other advanced frameworks are attempting to understand what happens when the known laws of physics approach their limits. Many of these theories suggest that the Big Bang singularity may not represent a true beginning. The apparent beginning may be replaced by a transition, a bounce, or a more fundamental process that extends beyond the observable universe. In these models, reality does not emerge from absolute nothingness. It evolves from conditions that already exist. This possibility has inspired entirely new ways of thinking about cosmic history. Rather than picturing the universe as a structure that suddenly appeared, some scientists imagine an eternal framework within which universes continuously emerge and evolve. Others propose that our observable universe is only one region of a larger reality. Still others explore cyclic models, where phases of cosmic expansion and contraction repeat indefinitely. Although these ideas differ significantly, they share a common goal. They seek to explain the universe without requiring an absolute birth. Of course, proving such possibilities is extraordinarily difficult. The farther scientists push toward the limits of cosmic history, the fewer observational clues remain available. This is one reason the question remains open. Current evidence does not conclusively show that the universe is eternal, nor does it conclusively prove that reality began from nothing. Instead, researchers find themselves in a remarkable position. Both possibilities remain scientifically meaningful. The search therefore continues. New telescopes, improved observations, and more powerful theoretical models may eventually provide answers that are unavailable today. Future discoveries could reveal subtle signatures hidden within cosmic radiation, gravitational waves, or the large-scale structure of the universe itself. Every new observation has the potential to reshape our understanding of cosmic origins. What makes this search especially fascinating is that it challenges one of humanity's oldest assumptions. For thousands of years, people have searched for first moments. We naturally expect beginnings because beginnings are part of everyday experience. Yet the universe repeatedly demonstrates that reality does not always conform to human intuition. The Earth is not stationary. Time is not absolute, space is not empty, and perhaps the cosmos itself does not require a birth. If that possibility is correct, then reality may be far more expansive than we currently imagine. The observable universe would become only one visible chapter within a much deeper history. The Big Bang would mark a transition rather than an origin. Cosmic existence would extend beyond the boundaries of what we can presently observe. The search for a cosmos that was never born is therefore more than a scientific investigation. It is an attempt to determine whether the universe has an ultimate beginning at all. The answer remains unknown. Yet every year, new discoveries bring us closer to understanding whether reality emerged from a first moment or whether it has been unfolding across an endless cosmic history. And if the universe was never born, then one of humanity's most fundamental questions may require a completely new way of thinking. The mystery would no longer be what happened at the beginning. The mystery would be why we ever expected reality to have one. If the universe truly has no beginning, the implications would reach far beyond cosmology. Such a discovery would not simply change a few scientific equations or alter our understanding of the Big Bang. It would transform the way we think about existence itself. Few ideas have the power to reshape so many areas of human thought at once. For centuries, people have searched for origins. We ask where species came from, how civilizations began, when stars formed, and what events led to the world we see today. This search for beginnings is deeply connected to the way human minds understand reality. We often explain things by tracing them backward through a chain of causes until we arrive at an origin. A beginningless universe challenges that habit of thinking. If reality never had a first moment, then the search for an ultimate starting point may be asking the wrong question. Instead of looking for a moment when existence suddenly appeared, we would need to understand how an eternal reality continuously evolves. This is a profound shift in perspective. Imagine reading a book and discovering that it has no first page. No matter how far back you turn, another chapter always exists. The story does not begin at a specific point, it simply continues. A beginningless universe would resemble such a story. Reality would not be something that emerged from non-existence. It would be something that has always existed in one form or another. One immediate consequence concerns the concept of cosmic origins. Today, many discussions about the universe focus on what happened at the beginning. Scientists investigate the earliest moments after the Big Bang. They search for clues about the conditions that existed at the start of cosmic history. But if there was never a first moment, the focus changes. The central question becomes not how did existence begin, but how does existence sustain itself over time? The difference may seem subtle, yet it completely alters the framework of inquiry. Instead of treating the universe as an event that occurred once, we begin viewing it as an ongoing process. Another transformation involves our understanding of time. Human beings naturally imagine time as a path stretching from a starting point toward the future. This image is reinforced by personal experience. We remember our past, live in the present, and anticipate what lies ahead. A beginningless universe suggests that time may be far deeper than our intuition allows. The timeline of reality would not resemble a road that starts somewhere in the distance. It would resemble an endless landscape extending beyond every visible horizon. No matter how far backward one traveled, there would always be more history. This possibility changes the scale on which we think. The 13.8 billion year age of the observable universe already seems enormous, yet compared with an infinite past, even billions of years become a relatively small chapter within a much larger story. The concept also affects our understanding of causality. In everyday life, causes lead to effects. We are accustomed to following chains of explanation until we find an origin. If reality has no beginning, then the chain may never terminate. Every event would emerge from earlier events. Every state of the universe would arise from previous conditions. The search for a first cause would be replaced by the study of continuous processes extending indefinitely into the past. This challenges one of the oldest assumptions in philosophy and science. For thousands of years, thinkers have debated whether an infinite chain of causes is possible. A beginningless universe would suggest that reality itself may operate according to principles that do not require a final starting point. The implications extend beyond time and causality. A beginningless universe would also change how we understand existence itself. Many people intuitively imagine existence and non-existence as opposites. If something exists today, we often assume there must have been a time when it did not exist. But an eternal cosmos introduces a different possibility. Existence is the fundamental condition. Non-existence is not the default state from which reality emerged. In such a universe, existence would not need to be created, because it would never have been absent. This idea represents a radical departure from ordinary intuition, yet modern cosmology repeatedly reveals realities that differ from everyday expectations. Space can expand, time can slow down, particles can behave like waves. The deeper we explore the universe, the more we discover that reality often operates according to principles that seem unfamiliar from a human perspective. A beginningless cosmos may be another example. It also changes how we view the Big Bang. In a universe with an absolute beginning, the Big Bang serves as the first chapter of existence. In a beginningless universe, the Big Bang becomes something else entirely. It becomes a transition, a transformation, a major event within a larger cosmic history. Its importance remains enormous, but its role changes. Rather than marking the birth of everything, it marks the beginning of the observable chapter of a much longer story. This distinction has profound implications for scientific research. Instead of asking what created the universe, scientists would focus on understanding the processes that produced the Big Bang itself. The search would move beyond origins toward deeper questions about the structure of reality. Entire new areas of investigation could emerge. Researchers might explore previous cosmic phases, eternal processes, or mechanisms that operate across timescales, extending far beyond the observable universe. The universe would become larger not only in space, but also in history. Another fascinating consequence involves humanity's place within the cosmos. People often view themselves as living relatively close to the beginning of cosmic history. In a beginningless universe, that perspective disappears. Human civilization would occupy a tiny moment within an unimaginably vast continuum. The observable universe would represent only one chapter among countless others. This realization can seem humbling, yet it can also be inspiring. It suggests that reality is far richer and more expansive than we currently understand. The universe would not be a temporary structure moving away from a single starting point. It would be part of an ongoing process extending beyond every horizon we can presently observe. The most important transformation concerns the nature of mystery itself. Today, many discussions about existence eventually arrive at the question of beginnings. What happened first? What caused the universe? Why is there something rather than nothing? A beginningless cosmos does not eliminate mystery. Instead, it redirects it. The mystery shifts from origins to continuity, from creation to existence, from the first moment to the deeper principles that allow reality to persist. The questions become different, but no less profound. They may become even more challenging. A beginningless universe would transform our understanding of existence by revealing that reality may not fit the narratives we naturally expect. The cosmos would no longer resemble a story with a first page, a clear opening scene, and a defined starting point. Instead, it would resemble an endless unfolding process whose history extends beyond every boundary we can currently imagine. If that vision proves correct, then one of humanity's oldest assumptions will need to be reconsidered. The universe may not be something that began long ago. It may be something that has always been. And if existence never required a first moment, then the deepest mystery of all may not be how reality started, but how an eternal reality continues to exist at all. The possibility that the universe never had a beginning is more than a scientific curiosity. It is a challenge to one of the deepest assumptions human beings have ever made. We naturally search for origins, first moments, and starting points, yet reality may not be structured in the way our intuition expects. The cosmos could be part of an ongoing process extending far beyond the limits of observable history, with no absolute beginning waiting to be found. If that is true, then the greatest mystery may not be what started the universe, but why we assumed it needed a start at all. As our understanding of cosmology continues to evolve, one extraordinary possibility remains open. The universe may not be a story that began long ago, but a reality that never truly began at all.